We are going to be talking about part C in section 5.6. This is integration with respect to y. As you would know, it may happen that sometimes the graphs, the curves can be expressed as x is equal to f of y, x is equal to g of y, and we may still want to find the area in between. If this is the case, then this is the prescription. This is going to tell you how you would do that. For example, your function could be x is equal to f of y. I'm looking at the first graph. The yellow curve is x equal to f of y. The blue curve is x equal to g of y, and the region is between y is equal to c and y is equal to d. This rectangular region we want to find the area of. The way you would find is we are going to write the area as follows. The interval is changing from c to d. C to d is on y, and then we are going to take the difference between the functions. The right function, the right curve minus the left curve. So the right curve in here is x is equal to f of y. The left curve in here is x equal to g of y. So area is equal to c to d f of y minus g of y dy. So this is the area that you would get. There are three versions you may encounter. The first version is a rectangular region like that. The second region, the second picture is like a triangular like that. Do you see that? This is triangular. And the last one is like this, okay? Be careful. You may encounter any one of these. The only thing you would do is you are going to take the difference, the right curve minus the left curve, and integrate over the interval. That's what you would do. Let's see this example. We have two curves. The blue curve x equal to y squared. The yellow curve is x is equal to y plus 2. The region in between is the blue colored shaded region. And the area you can find right function minus the left function, the right function minus the left function, and evaluate it on between 0 to 2, because y is changing from 0 to 2. You just integrate that and you get the answer. So it's going to be like y plus 2 minus y squared dy, 0 to 2, you integrate that. Okay, you can do like the first way, like you can top and bottom curve, but you have to separate this into two separate regions to do that, so it's an extra work. That's why we have this new approach to solve such problems. Another way you could do is you can say you could use the first option where you would just define the area of this, all of it, and then you're going to just subtract the area of this triangle, which you can easily find the area of this triangle. 2 times 2 over 2, which is 2. So square root of x, you're going to write integration square root of x dx from 0 to 4, and then minus the area of this rectangle. But you may not be lucky, as in this example, you may not have such nice area to subtract from here to get the blue colored region. This is just an option. And also you should observe that x is equal to y squared can be written as y is equal to square root of x, right? They are the same thing, but y written in terms of x. The previous one is x written in terms of y. Alright, so same question here. Okay, this example we have, this is easy. You can do in either way. You can either use right function, right curve minus left curve, and integrate over y dy, or you could do top curve minus bottom curve. But since in this picture it's already given y f of x, y is equal to g of x, you can use the first option, top function minus bottom function, integrate over 1 to 2. Otherwise you would have to rewrite this in terms of x, and which you would be in trouble, kind of trouble. It would take longer time, so I don't recommend to use the second option. Use the first option in here. And this part is, I'm going to give you solve some problems on that, but before I do, there's a little note here. We may have some piecewise continuous functions like this. If that's the case, how would you integrate them? You would integrate them piece by piece. That's just a reminder for you. Okay, we continue again. These are our class fall 2019 class notes. The area, if you have right and left curve, and if you want to find the area in between, then this is a recall. A is equal to integral from c to t f of y minus g of y dy. And here is one example for you guys. Find the area of the enclosed region by enclosed by y is equal to x minus 1 and y squared is equal to 2x plus 6. You can draw the graphs. How would you draw? Y is equal to x minus 1 is easy to draw. Y squared is equal to 2x plus 6 is also kind of easy because you can just write x in terms of y. It's a parabola. It's like x is equal to a times y minus x h squared plus k, and the vertex is going to be here. What's hk? I think, let me see, just a sec. Yeah, let's do it together. So how would you convert this to this representation and then find the vertex of the parabola? First you isolate x and you get y squared minus 6 over 2, and then you simplify a little, 1 over 2 y squared minus 3, and then this is the same as 1 over 2 y minus 0 to the second power minus 3, and then here the y coordinate is 0 and the x coordinate is negative 3, so the vertex is negative 3 to 0, and here is the parabola opening towards right because the coefficient of y squared is positive. That's why it's opening towards right. And then look at the region in between. This is the region. If you use the first option, you have to separate it into two pieces, which is going to take a lot of time. So let's use the second option. And the right curve is this curve and the left curve is this curve. You're going to just take the difference between the two. And what is the domain? Y is changing from negative 2 to up to this point. Actually, we have to find that point too. Okay, actually, this shouldn't be square root of 6 though, is it? Let's, okay, solve them together. We are going to find the points. Yeah, y is equal to 4, not, yeah. So y is changing from negative 2 to 4, so their intersection point is going to go from, and this is an extra step that you have to do, negative 2 to 4. It's going to go until negative 2 to 4, so the domain is going to go, yeah, this should be, there's a typo here by the way, not square root of 6, this should be 4. So we have to, let's see, pardon, the boundaries are wrong. This should start negative 2 to 4, okay, because this is the intersection point. It's going to go until, there was a typo in there, okay, negative 2, the y, because we are integrating over y, negative 2 to 4 has to be the correct integration. There's a typo in here, be careful about that, so the result is not going to be right here. Negative 2 to 4 it should be, okay. So you then right curve minus the left curve and you are good to go, because you're integrating over y. Thank you.